Free fall, more problems. Worksheet 2. Let's get right into it. Hopefully you did worksheet 1, looked at the video for that, and you're feeling okay. Maybe this one a little bit better for you. That's the idea. That's called learning. When you try something and you practice and then you look for information, and yeah, it's good. So let's see if learning happened. An arrow is fired from the ground straight up with an initial speed of 15 meters per second. Of course, it's free fall, so I get that negative 10 for free. Initial speed is 15. To what maximum height does the arrow reach? Remember, maximum height is going to happen when your final velocity is 0. And the maximum height here is going to come from that delta y for us. So, looks like we got for part A, Vf squared is equal to Vi squared plus 2A delta y. Vf is 0. Vi is 15. 2 times negative 10. And then the delta y is what I'm looking for. So, time to do math. So about 11.3 meters. Alrighty. What's the total time that the arrow is in the air before it strikes the ground? Okay, so if we're going all the way up and back down again, then this is not 0 anymore. Right? We're not talking about going to the peak. We're talking about when it goes all the way up and back down again. And I don't think we had an example like this in the free fall sheet number 1. What's the thing that we know if it goes from the ground back to the ground again? What's the delta y? What's the change in its position? If it goes from the ground right back to the exact same place on the ground again, then its displacement is 0. And total time, so that looks like it's the equation delta y is 1/2 a t squared plus vi t. So delta y is 0 equals negative 5 t squared plus vi t. And that's going to be, you can graph that if you want, it's going to be 3 seconds. All right, that was part B. Okay, that's number 1 done. Good. Let's go this way. Number 2. A diver springs upward with an initial speed of 1.8 meters per second from a diving board that is 3 meters above the water. How long is the diver in the air? If you're 3 meters above the water, if you start at 3 meters, there's the diver headed down toward the water. If you start here, that's a little upside down person. You see that? You're starting at 3 meters and you're ending at 0. Right, so you're going down 3 meters. So that means you have a displacement of negative 3. Easy to miss that negative sign again. Be careful. Now, of course, their initial velocity we got here is 1.8, and it's a free fall problem, so this is negative 10 meters per second squared. All right, so that's enough information. How long is the diver in the air? That's a time, so that's going to be remember how to pick the equation that you need, right? Which one of the things are you missing? So like here, looking for time, so I don't care about that. So I look at my notes and I see the equation that doesn't have the F in it. Hope you watch those notes. That's kind of important before you can do this. Negative 3 equals 1/2 a is going to be negative 5 t squared plus VI is 1.8 T. This looks like one of those calculator graphing problems again. All right, so let's see what we got. -5 squared plus 1.8 x plus 3. There it is, right around 1 second. So I'm going to set the max and min to 0 and 2. It looks like it might be less than 1, but hard to tell here. So let's be safe and go from 0 to 2. So I go second, calculate the zeros, and left bound 0, right bound 2. And it looks like it's at 0.98 seconds. All right. Part B, what's the diver's final velocity when he reaches the water? So that's all the same information here, right? When he reaches the water, that is that full displacement of -3. So that looks like my VF squared equals VI squared plus 2A delta Y. So VF squared, that's, the VF is what we're looking for, 1.8 squared plus 2A delta Y. Time to do math. So I got the square root of 1.8 squared plus 60. Now this is that plus or minus situation, because I'm solving for VF squared. So what's it going to be? Is it going to be up or down? Diver's velocity when he reaches the water, that is going to be down. All right. Number 3, rock thrown upward with an initial speed of 12 meters per second. From a bridge that's 83 meters above a river. How long does it take the rock to reach the water? So if we're going from 83 meters above down to the river, hope they don't hit that guy's van. You know about the guy who was in a van down by the river? 83 meters above river, how long does it take the rock to reach the water? So how long? That looks like it's going to be delta y is 1/2 AT squared plus VIT. Back to the trusty calculator. So let's see what we have this time. It's going to be plus 83. That looks good. And I'm going to graph that. Looks like it's in between 1, 2, 3, 4, 5, and 6 seconds. So between 5 and 6. 5.45. And part B, what's the final velocity? It's pretty much identical to the last problem, isn't it? Practice makes perfect, or makes better anyway. VI is 12 plus 2A delta Y. So let's see. Is my final answer, I'm going to get that plus or minus here because I have to square root something. It's going to be positive or negative. The rock going up or down. It's going to be going down, right, when it gets to the river. So that final velocity is negative 42.5. If you're making slightly different choices than I am about rounding, that's okay. All right, last one. Ball is thrown directly upward, and 8 seconds later, it returns to the point of release. All right, what does that mean? So acceleration is definitely going to be negative 10. It's thrown directly upward, and 8 seconds later, it returns to its point of release. So that's like this situation, right, where you throw it up and it comes back to the same place. So that change in height is 0. What do we want to know? How fast was the ball initially thrown? Oh, only one part. How about that? So how fast was it initially thrown? That's this right here. So that looks like my delta y is equal to 1/2 at squared plus vit. So delta y is 0. 1/2 a is negative 5. The time is 8 plus the vi is what I'm looking for, times 8. So it looks like that initial velocity must have been, pretty sure that's going to come out to be 40. Yep. And should that be positive? That makes sense that it's positive. Yeah, we're not doing that's not squared, so whatever sign we get should be right. How fast was the ball initially thrown? Up, 40 meters per second. There you go.